We are going to cover a few topics that are revision hackathon. Okay, so if you have recently joined, you can type me in the chat box. Great, here on, that's great, not a problem. So people who are watching us on our social channels like YouTube, LinkedIn, Facebook, Instagram, Twitter, TikTok, any other place, you can use the comment section to reach us out. So there's a way where we can see your chat and all. So go ahead and keep this interactive. So this session, we are going to keep it very short to specifically a half an hour, right? So in this will be like an introduction to many people who have recently joined and also a continuation for the people who have been going through our previous cycle of hackathon, right? So currently we are in module 7. We are revising module 7. So before I go to module 7, like people might be like, I've just started, what is module 7? Let me go ahead and point you out in the right direction. Okay, so I'm just going to share my screen here. Great. Yeah, so now if you log into your Teachable, right? So each of you has access to your own Teachable account. You can, once you log into your Teachable, if you can bronze, silver, or gold, you'll have the view of it similar to this, right? So you can start from the beginning. So all of the sessions are already available for you to start on, right? So now the live session keeps on happening in a repeated cycle, right? So first we started from 0 and we continued 1, 2, 3, 4. Right now we are in the 7th module. And after 10th module, we are going to start from the beginning again. So these hackathons keep on happening in the same cycle, right? So you need not worry. And if at all you have query in any of the module, let's say you are in module 3, and if you have a query and we are in module 7, while revising towards the end, you can ask your questions as well, right? So this, that is how the format of this is going to be, right? So if this is clear, type C in the chat box. Yeah, so people who are on our social channels can type on the comment section. Great. Thanks, Arjanya. Thanks, Vijay. Thanks, Lakshman. Thanks, Ashish. Right. So people who have recently joined, you have to go and start your first lecture. If you've not already done, you have to go ahead and begin. So it's a private video visible to your email access, right? So you can just go ahead and start understanding all of it. So we have also done a revision of the same. The revision recordings of the revision hackathons will be available in your inner circle. But that would be a repetition of the actual lecture. So I would request you to go ahead and complete the actual lecture as well. So if at all you plan to attend both, you can still attend the hackathon that is happening right now. And you can briefly understand it. You don't have to deeply understand it right now, but you can continue your journey and also the current hackathon. Right? Great. Okay. So we are going to revise a few concepts on module 7, right? So because we are going to keep this session short, I'm just going to revise the concept that we've learned in the module 7, right? So where is module 7? The module 7 is here. We're going to revise the concept that were covered by Professor Pandurangan sir in this particular lecture, right? So if at all you have attended that lecture or revision of that lecture, you can go ahead directly to the lab or quiz portion of the scene. Great. Okay. So let me see if my screen is being shared. Okay, amazing. So in this session, we are trying to understand what are contents of a blog, right? So whenever we see a blog, every blog has its blog header, right? So in the whole of the blockchain. So people who have recently joined also can understand this briefly. It's we're not going into the technicalities or math portion of it. So it is easy for you to understand. So every block on the blockchain has its own header, and these header consist of few more other elements also, right? So we are going to understand that. So now this block size and more details we'll try to understand. So now when you look at block header, So this is like a piece of information in every block that connects to the previous block, right? So as we visualize, blockchain is not like a chain of blocks chained together with some link. The link is a piece of information, a numeric number, which is going to be like this. For example, this is a new block, and this block says I am connected to block 5. So the number, the previous block's hash, which is 5, would be there in it. There's no actual connection, but then that is how others know that this is connected to the previous block, and this is the next block in the sequence, right? So each block header consists of a little information, version number based upon the version of that particular block. So that is something, it comes as a default. You don't have to worry about it. Previous blocks hash, previous block headers hash, right? So hashing and all, if at all you have recently joined, we have covered that in detail in our 3rd, 4th modules only, right? So once you start coming from the beginning, you will be able to understand that in a better way, right? So if at all any of you face a challenge in trying to access these points and all, you can always reach out. I'm just going to share the details here. Okay, now in the same block header, you can see there is something called Merkle root, which we have discussed in our module 6, right? So Merkle root is nothing but your hierarchy of how the transactions are laid out in a particular block, right? So we have understood that in our previous blocks. So you need not have to worry. If at all there is any challenge, you can go through module 6 of the same, right? Okay. So I request the new members joining to do it so that it becomes helpful for everyone. Great. Timestamp, the time at which the miner started mining it, and then the difficulty, target, and nonce, right? So we'll also discuss more about this. So now specifically more about nonce. Now all of these have some or the meaning which is easy to understand immediately. But what is nonce? Now, if you see nonce, nonce is a number, a random number, which is very difficult to find, right? So when a person finds this nonce, a miner finds this nonce, he will be able to solve the cryptographic puzzle, right? So we'll also understand what is a cryptographic puzzle. People who have previously joined understand it well. So this is a nonce that a miner tries to get, and once he gets that, he adds that nonce to all the list of transaction and does a hash of the same. And the nonce is such a number, the whole hash, whatever is getting generated, is less than a set threshold. This is the challenge. The challenge is to find a nonce with the hash of the whole transaction using that nonce will be less than a threshold, right? So we'll try to understand more about it, right? So that we have previously discussed, but right now we'll try to understand how, because the blockchain is all peer-to-peer and a very large chain of network of all these nodes, how all of them stay in common agreement, right? So that is where we come to know about the consensus, right? So the common agreement is called consensus. Consensus, the actual definition is agreement itself, right? So the consensus must evolve among all the nodes, right? So for example, if I get to create a new block, so who gives me the authority to create a new block? So why should I only generate? So everybody has to come onto a common agreement. So there is a set protocol written out while the blockchain was created, the initial Bitcoin was started out. So that is where this consensus protocols have all been defined in there. So at the time of Genesis, all of this is defined, right? So how do everyone come to the common consensus or the agreement? So that is what we'll try to understand. Now, who decides who is the winner while somebody is mining for a block, right? So how everybody is agreeing that, okay, now this person is a winner. Why not other person is a winner, right? So that is what we'll try to understand, right? Okay, now what happens is whenever a person he has to go ahead and mine. He has to do some work, right? So for example, if a person who is at a construction place, how do we know that he has worked? Let's say the bricks have been laid and a wall has been created, so that is proof of work, right? So some work has been done. Similarly, in mining, the person is doing the mining, the proof of work also has to be set. Now, but this is all virtual, so how does all of the nodes, all of the miners, all of the blockchain individual people know that this person has put in enough work so that he can create a block? So that is what is proof of work. So first, a person has to work a certain amount, do certain amount of work to be able to mine, right? So after that, he will be able to solve a puzzle, and because he has the key or the solution, we know that he has worked, which becomes proof of work, right? So there has to be a winner and a reward. And so now how do we ensure each node does some amount of work or computation before they start mining, before they start becoming the winner, right? So how do we ensure? So at the time of the genesis, all of this has been set, right? So now, for example, let's try to understand with a common example. For example, if you have to toss a coin, what is the probability that it will be heads or tails? It is 1 by 2. So because you need one outcome that is desired, heads or tails, by 2. 2 is the total possible outcomes, right? So now, similar to rolling a die, the probability is 1 by 6. And now what 1 by 6 says is how many attempts you have to throw to get a dice. Like for example, if you have a dice and if you have to get one, so how many attempts do you think we might have to make to get that one, right? So if you have a guess, you can go ahead and put it on the chat. How many attempts do you think we have to make to get a one on the dice? A generic question. Yes, Ashish put up his answer. Vijay, Saujanya. Great. Okay, so there are n number of attempts have to be made. There is no set number of attempts, like after 6 attempts, 5 attempts, 4 attempts, you get a 1. It is not sure, right? So now, even if you go through the actual module covered by Professor Pandurangan sir has explained this in a very clear, concise manner. So to throw a dice, we are not sure how many number of attempts we can make, but there is a possible number of attempts that could be made like a rule of thumb, right? So the thing is 1 by p. Like for example, if the probability of getting one specific number out of 6 is 1 by 6, then how many attempts have to be made is 1 by p, which means 1 by 6, which is 6 attempts. So we can guess like out of at least 6 attempts, at least there could be 1, right? So this is how we calculate the expected number of attempts to get a positive outcome, which is 1 by p. Right? Similarly, let's try to put this in context for our blockchain ecosystem, right? Right. So similarly, probability is number of favorable cases by total number of cases. And for example, similar to the dice example, let's say out of a class of 30 boys and 2 girls, which is like 32 people altogether, if we need to calculate the probability, 2 out of them, like if the question is, what is the probability of you opening one chit out of all these names, that will be a girl's name, right? So there are 2 girls, which is the number of favorable cases. The total number of cases is 32. So 2 by 32, 1 by 16. So now how many attempts the person has to make to at least like expected number of attempts a person has to make to get a girl's name, which is 1 by 16, which becomes 16. Right. So now nonce, if you remember, what I'm telling here is, if you are trying to do hash of the transactions that are there in a block. So people who have recently joined, don't get overwhelmed if this feels like numerically exhaustive or something, you can just start from the beginning. I've shown you on Teachable from where to start. So you can start from there and it will all become very clear. If at all you have a question or something, you can always reach out. So that's not a problem, right? Now, so what is this nonce? This nonce is that magic number that a person, if he finds, he'll be able to solve that cryptographic puzzle. Okay, so now what is the cryptographic puzzle? It is hash of M, which is all the transactions. When added with the nonce number, it should be less than a set threshold. We'll try to understand that better. Like for example, if somebody is a miner is trying to hash all the transactions, and every time he is trying to find that number, the nonce, and he starts from 0, 1, 2, 3, and he continues going forward like that, right? So he goes forward, and at one particular number, he will be able to get the hash to comply to this particular equation. So whatever hash comes out, it will be less than a set threshold, right? So now, if at all we have to see the nonce, let's say if somebody is trying to do a hash, right? If you are calculating in terms of binary zeros and ones, the length of the hash would be 256 characters, right? So which means the number of hash values that will be there is from 0 to 2 power 256 minus 1. So that, because it could be either 0 or 1. So this is 2 to the power 256. Because we start from 0, it is 0 to 2 to the power 256. Now 2 to the power 256 is a very huge number. It's like a very, very huge number. Even if you try to calculate, it will give you a scientific notation, right? It is very huge. So those many hash values are there existing. So finding one nonce such that this hash value that is getting generated is less than a threshold. That is when that nonce becomes valid and he becomes the winner, meaning that he has proved that he has made some work. He did some work, right? So we'll try to understand that a little bit with an example. So the probability of the hash value being less than a set threshold value T is the favorable number of cases, because there are T number of cases that will be less than the threshold. So T by total number of cases, 2 power 256. So the probability of a hash value being less than a set threshold is T by 2 power 256. Like let's say the threshold is 10. I'm just giving an example. So it is 10 by 256. Let's say that threshold is 100 crore. That number divided by 2 power 256, right? So, but this itself is a very tough probability because the denominator is very high, right? So because the denominator is very high, the probability of finding the hash itself is very small, right? So it's a very small fractional probability that a person has to generate a hash in general, and it being less than a set threshold is even smaller. So T is called a threshold. Now this threshold is something that auto adjusts. So we'll talk about threshold in our upcoming sessions. So right now we'll try to understand more about nonce, right? So this particular session is specifically helping you in try to understand this nonce, right? So now let's say the hash of the combination of all the transactions combined with the nonce value, if it is less than a set threshold, then that person, the nonce, whatever number he has found, that person becomes a winner, and this nonce get added to the block header, right? Because we said in the block header there is a portion where the nonce is already there, right? So you have got a nonce such that M is the transactions validated onto the block, right? So M is all the transactions, and hence nonce is nothing but number used only once. So this number can only be used once, and this is the key that will make this hash less than the threshold, right? So let's try to understand. Okay, now I'm just going to share with you a pictorial view to help you understand this. Okay. Let me share. Okay. Let me share my screen. So even people who have recently joined also, you will try to understand. It's very simple. This concept alone. So we are not going to get into more of maths. Okay. Now let's try to understand nonce. Okay. Now let's just say there are 3 miners who are trying to mine. Meaning here mining means they have to solve a problem. And if you remember, the problem is trying to find a hash which is less than a set threshold. Okay. Now we'll try to understand threshold later. But here we are trying to understand nonce. Now these 3 people are trying, and the person in the middle, the miner, he is able to find a number where the hash of the whole transactions is less than a set threshold. Now, what is hashing? If you are new, hashing is basically a way to compress and make the number a little difficult to decode, right? So we are going to encrypt it. So it's an encryption way, right? So a person is trying to encrypt all the transactions, and adding to that, he's adding a number nonce. So he has to find that nonce, and the probability for a person to find that nonce is very less. So it's a very difficult problem. So the creation, while the creation was happening, it was set in a way that each miner has to minimum set 10 minutes to generate a block. So it will take at least 10 minutes for a person to generate a block, meaning 10 minutes of work has to be done by anyone, right? So that is one thing. Okay. Now let's just say this person was able to find a nonce. If he has find a number which lets him solve the cryptographic puzzle, which is nothing but the hash added along with the nonce is less than a set threshold, then he'll be able to upload the block, right? Not everyone will be able to upload the block. A person has to find the nonce number only used once, and that should satisfy the equation of the hash being less than threshold. Now, once this person finds a nonce, the other people verify that particular transaction. So now that particular process. So how do they do that? Finding a nonce is very difficult, but verifying the nonce is easy because he's already generated the number. They will just use that number. Automatically, the output will be, if it is less than threshold, then this person has done the enough work to be able to get the rewards of the block or become a winner, right? So that is how this happens, and the other people verify. Like, for example, to lay all the bricks in a construction place is difficult, but to verify that it is done properly, it is easy. You just have to go and watch it. Right? Similarly, if to solve a Rubik's cube is difficult, but to verify, you can just see all of the colors have to be same. Right? So that is how the verification is easier than finding the nonce. Right? So now this person has found the nonce. That is when he'll be able to upload the block. Right? So now a person, when he found the nonce, the number along with the data of the transactions, then he's going to hash all of the inputs that are there within that particular transaction, including the nonce, and that hash generates this alphanumeric string like this, which is the actual hash, and this hash goes into the block header, right? So if, for example, a new block gets created, it will have the hash of the previous block's header, right? And this is if somebody is able to find this hash, it should be and this has to be less than threshold, right? So this is the proof of work that a person puts out onto the blockchain network, that I have found a hash which is less than the threshold, and you can verify that. So that means he has done the work, and this block hash is nothing but his proof of work, right? So that is only when he's able to generate that particular block, right? So similarly, every person who generates a block creates a block hash, right? And that block hash was possible only because he found a nonce, a random number. The probability of finding a random number, the nonce, is very low. Still, he was able to find that because of which he had to do a lot of computation, and then he found it. So there is proof of work, right? Having this block hash itself is enough proof that he has done his work, right? So now, if you understood the concept of nonce, type U in the chat box. Even people who have recently joined, if you understood the concept of nonce, type U in the chat box. Thank you so much, Vijay. Thank you, Aaron. Great. Really nice that you recently joined and understood it. Yes, thank you, Prashant. Thank you, Sharayu. Thank you, Niranjan. Thank you, Raja sir. Yes, thanks everyone. So this is the concept of nonce, right? So I will also request each of you to also understand more about it by taking up the quiz, because right now our focus is for everyone to also go through the actual lecture, not just the revision. So we request everyone to go through the lecture given by Professor Pandurangan sir to have a better and deeper understanding as well, right? So we're going to keep our hackathons short so that we will help you progress and clear your doubts, and you go forward and finish Professor Pandurangan sir's lecture, right? So with this, we'll conclude today's hackathon because we want to contain in this only the topic of understanding nonce. But as we go forward, tomorrow we'll understand more about consensus protocol. And people who have been in our previous cycle of hackathon, we have come to the end of the most of the concepts, right? So the next modules will be more of solidity and a little to coding. So the upcoming session, we will cover a little of introduction to solidity and understanding how to code, right? So in the meanwhile, people who have recently joined, I request everyone to go and start the journey of going through Teachable, right? So let me go ahead and share my screen and show you people who have recently joined also how to access the same, right? So this is going to be a Teachable here. So you have to go and access all the content, and whenever you have a query, you can join the hackathon or reach us to get your query solved, right? So if there's any query in today's contents, you can go ahead and ask, put it in the chat or unmute and ask. Else, you can, if everything is clear, type C in the chat box. If everything covered today is clear, type C in the chat box. Thank you so much, Vijay ma'am. Thanks, Vijay. Thanks, Sharayu. Thanks, Arjuna ma'am. Thanks, Roshni. Thanks, Ravinda sir. Okay, so with this, we conclude today's session. If there's any other things or anything, you can always reach out. I am writing the email. Yes, so if there's anything, you can always go ahead and reach out on the same email. Right. So there's also a comment section in your Teachable. If, for example, if you have a challenge in module 3, there'll be a comment section. You can even write your comments there. We'll answer it from there. The best way also is to access the community portal and put your queries there. Right. So we have the community activity is higher than usual. So you can go ahead. Now we are trying to make it more active. So I request everyone to also post your questions on the community because there are many people who have already finished or progressing in their journey. Many people who are beginning, so everyone can help, right? So give us gain is the concept that works on the community, right? So thank you so much, everyone. I hope for a very good rest of the day. And if there's any query, definitely do reach out on the community as well. Thank you.